If you have been, if you still remember the very first few classes that we discussed, right? So we did discuss something about virtualization. So we had VMs, right, on the physical machines that we created, on the bare metal, that is on the actual host. We had virtual machines that we were using, and in these virtual machines, we install number one the operating system. Number two, let's say the HTTPD Apache web server and many other applications, software, and then we used it like we were doing. Similar, something similar is what we have been doing on AWS as well. So we have these EC2 instances, which are nothing but virtual machines running on some particular hardware, which is out there with AWS, right? So applications in the real world, how they are actually working is we have something called as the hardware infrastructure. On top of this hardware infrastructure, we have the operating system. So the operating system could be Linux or it could be Windows, right? It could be either of them. And on these, we are installing the libraries, dependencies, and then we are installing the applications on top of it. So this is exactly how the scenario has been so far till the time we have been discussing AWS, right? We used to create an EC2 instance, and on top of that EC2 instance, we created a web server, though we didn't install any databases or messaging and caching queues, but overall, this is how it is working. Now, the next kind of a scenario of how it is being deployed is, let's say you have one particular, let's say let's say you have a VM, right? And on top of that VM, you are actually installing multiple things like we discussed over here. You're installing the web server, you're installing the database, the messaging queue, and let's say Ansible, which is used for orchestration, is also being installed over there. Now, there is a likely similarity that could occur wherein, let's say, the application 1, the 2, and the 3 that you're installing on that, right, maybe would be dependent on one common library or package, right? It could be dependent on one common library or package, which is being used by all the three. Now, so far so good. There is no problem if a single package is being used by all three applications. So that is actually a good thing. We are not duplicating the packages. Is actually a good thing. But then the problem comes when you're trying to upgrade, when you're trying to upgrade either A1, A2, or A3. So what actually happens is, let's say you are upgrading A1 from version 1.0.2 to version 1.2.3. Okay, let's say this is the version that you are going to upgrade this to. The problem is when you upgrade this to a higher version, there is every likelihood that these libraries and packages that are installed on the server might also need a bump up. That is, they might also need an upgrade. Okay. So what happens is when you are installing or updating this, let's say the Apache web server, along with the Apache web server, there would be many dependent packages and libraries that would be updated along with the upgrade. Now the problem comes when service A2 or service A3 starts to fail because of the upgrade. Why? Because A2 is still on dependent on the older version of that particular library or package. A3 is also dependent or still is using the older version of the package. Because this library has been updated, because you updated this particular library, a2 and A3 starts to fail. This is what we refer to as the matrix of hell, wherein if any one of the dependent services or libraries get updated, compatibility and dependency issues will pop up. And because of an upgrade of one particular thing, the other applications or services might stop functioning at your place. This is how we have the current scenario. Now, what is the solution? We have a very good solution. So, what we do, we create individual VM for individual component. We have been creating individual VM for individual component. This is what we have been doing so far. So on the same hypervisor, this is the hardware. On the same hardware, we are creating multiple VMs, and then we are installing each thing over there. Now the problem with this installing each VM or creating a separate EC2 instance is the operating system which is used to run this, right? The operating system is itself consuming, let's say, 40% of the resources, that is CPU, memory, and stuff like that. Let's say 40% of the resources is being consumed by the operating system itself. So, in a longer picture, in a long run, can I say that the hardware is being underutilized, right? Now, let's say 40% is used by the operating system. Let's say another 20% of the CPU is CPU and memory and everything is used for the service, right? So 40 plus 20, 60. So there is another 40% of the resources which are lying idle. Now we can't go ahead and decrease the resources on this because sometimes the application or the service peaks when the demand is high, the load of the service could go high up to 40% or something, and then there would be a resource crunch on this. So this is one of the issue with the current setup wherein we are having multiple VMs and then trying to install each one over there. The number first one is the operating system itself is consuming a lot of resources. That means of the three VMs, now you need to consider the hardware resources on the physical machine, that is the CPU memory on the physical machine and the disk on the physical hardware, right? Half of it is already being used by the operating system. Only a very small fraction of these resource on the hardware is actually being used by the services that are running inside the VMs. That is one big problem. The other problem is we just discussed single upgrade of the libraries of a service will break other services. That's number one. Setting up time, right? So the amount of time it takes to set up the network, the EC2 instance, and then installing all the packages and the dependencies is a very tedious task. So we only did a very simple example of installing HTTPD as a service. But then let's say you have to install Jenkins, which is the next topic that we'll be discussing, on a server, right? For Jenkins to be installed, you first need Java, right? You first need Java to be installed on the app on the server, and then you go ahead and install Jenkins, right? So this is not an easy setup when it comes to the installation. When I say easy, it's definitely something which is not going to complete in, let's say, in 2 minutes or 3 minutes. It's going to take its own time, maybe 20 minutes to 1 hour to get the settings right. Now, if there is a mismatch in the Java version and the Jenkins, right, the Jenkins software or the service will not come up. That's another problem, right? So this is one long time setup for developers. Now, there's also something called as OS preference. Now, if you see it, I have been using Amazon Linux as the choice of the operating system on AWS. Now, do we have Amazon Linux as a VM on my local machine? No. I could be running a VirtualBox VM with maybe Ubuntu or CentOS because these are the free versions. I might not be using Amazon Linux on the local OS or the local testing lab, right? That could be one. Or there could be some teams which prefer Ubuntu Ubuntu has its own package management system. That is, Ubuntu has its own package manager. So Ubuntu uses apt, right? apt as the package manager. CentOS uses yum as the package manager, right? Windows as a Choco. Choco is a package manager in Windows that can be used. So these are different package managers. Now it's not 100% guarantee that all the package managers, right, will be updated at the same time when a package is being updated, right? Yum could get a release maybe a week earlier, and APT could get a release maybe 2 weeks later, right? So that is very much possible. Depends on how soon the packages are being updated. Unless it's a 0 day vulnerability or stuff, right? Packages will take time to get uploaded. So different teams using different software. Now, if different teams are using different software, will you then be creating different VMs depending on different software? No. We will still be going with one flavor of VM on the cloud, right? It would either be Amazon Linux or it would be either Ubuntu only or something. We are not going to have a mix and match saying that team A only uses Ubuntu, so we'll have Ubuntu servers. Team B only uses CentOS, so probably we'll have Red Hat Enterprise on production. Right? So that's not something which is done in a production environment. And the dev UAT and prod environments, if we go with this original definition, right, have different hardware and software configurations to save cost and licensing. What do I mean by that? So in production, I could go with Red Hat Enterprise Linux, but when it comes to QA or dev, I will not go with Red Hat Enterprise. I might go with CentOS, right? The CentOS is also uh, Red Hat based, right? So it would give you the same functionality and flavor. The only thing is you don't have an official support for CentOS machines. The repositories, the package manager and everything is Yum, so it still works, right? But the behavior in which CentOS machines function under upgrades is totally different than the functionality that is there in the Red Hat. If you do a yum hyphen hyphen update hyphen hyphen security update or something, Red Hat is only going to install few of the things, right? Whereas CentOS, it will install everything. It's as good as doing a yum update hyphen all, right, on CentOS. Even if you only select security patches, it's not going to differentiate between the security patches and normal stuff, and it's just going to do everything, right? So this is the current scenario that we are in now. That's the current scenario. What do we do? Uh, This is where the concept of containerization came in. What is the use of containerization? Containerization is actually creating smaller containers or isolated environments, right? Isolated environments for your services to run. So we have isolated environments. This isolated environment is provided by containers, and these containers are actually running in your system. Now, the software that is needed, that is the kind of a hypervisor that is needed to run these containers, is nothing but a Docker, right? So developers always wish to work independently, having no dependencies and other stuff. And the best way forward is to isolate these things into smaller boxes. Now, the development team for a web server, the database, the messaging server, and the orchestration tool is definitely going to be different teams. These are not going to be individual team developing all the four things, right? So there would be a different team trying to work with the web servers. There could be different teams trying to work with the databases and so on. So what is the best way forward? The best way forward is to isolate each environment in such a way that container one belongs to web server, container two belongs to the database, container three belongs to Redis, and container four belongs to Ansible. And this is a very good way of doing it. Now, what is happening is, how are we providing isolated environments? How are we providing isolation? The isolation is provided wherein each container is going to have its own libraries and dependencies. Dependencies are nothing but the dependent packages that are needed for the application to run properly. So each container is going to have its own dependencies. If that means that Java is going to be present in this and this, yes, that's the case. If it means Python is going to be present in these two, that's the case, right? But then isolated environment means duplication of packages, so nothing can be done over there. But the good thing about containers is the containers are very lightweight. Containers are very lightweight. If you compare an operating system with a container, right? If the operating system is, let's say, around 2.5 GB in size, I'm talking about the base image. The container is around 20 MB in size, right? So the container is very small, whereas the operating system is very, very, very huge in terms of size. Now, containers for isolation. Containers are completely isolated environments which have their own number one process, network interface, and mounts. When I say mounts, it's actually volumes, right? It's actually volumes that I'm talking about. Mount is nothing but volumes. So a container will have its own process, network, and volume, right? And the container tool that we are going to use is Docker in this case. Docker is installed on the operating system. Now, typically what happens is generally we would believe that each container is having its own operating system, right? But that's not actually the case. Each container is only having the software which is needed for running that particular service that you are intending to do. We'll be looking into examples in depth, so don't be afraid. In this image, what I want to show is the container, right? Uh, let's actually try to understand how an operating system is designed, the OS, right? The OS comes in two broader classifications or subgrouping, if I have to call it. The OS kernel. The kernel is where you have all the drivers and everything, which is actually going to interact with the physical CPU, RAM, storage, network, and everything. It is the OS kernel which is going to interact with these physical devices. It is the software on top of the OS which is actually going to give you the look and feel of your system. That is, uh, so I am running Windows, right? So Windows has a different OS kernel. If you're running Linux, Linux has a different OS kernel. So these two are separate OS kernels. But if you compare Mac with Linux, both of them are based out of Linux, right? So both of them are out of Linux. Mac has invested a lot of money to creating a very nice graphical user interface. Linux, whereas Ubuntu does has a very good graphical user interface. We also have other CentOS based images which can be used as desktops. But then Linux is more towards server OS, wherein it's a black screen, very less of software components that are needed to actually load stuff and the graphical user interface and everything out there. It's more towards the OS kernel and customizations on how it can be done. So that's why Linux is preferred much, because the overhead of other services that are needed to at the boot time is very less when compared to Windows. Now, this is Ubuntu, this is Fedora, this is SUSE Linux. So this is Ubuntu. I'll just write it out so that you know that this is Fedora, this is SUSE Linux, this is CentOS, right? So these are the different OS kernels that are out there. Now, the dependence on OS, it could be an interview question for you. Does a container has its own OS kernel? The answer is no. The container will not have a kernel of its own. What it does is, with the help of Docker, it is going to interact with the kernel of the operating system, or the base operating system, or the host operating system. In my case, Windows is my operating system that I'm using. So what is Docker going to do? Docker is going to interact with the kernel via Docker. So the container is going to use Docker to interact with the kernel of the operating system, and then it is going to talk to the physical hardware. So these containers are not going to have a kernel of its own, and that is the reason why OS is having a very huge footprint, because it has a kernel of its own, and containers are having a very small footprint because it is not having a container of its own and is using that of the server itself, or the base OS itself. Now, because of this dependency, running a Windows container on a Linux one is not possible, right? So if you are working on Mac, or if you're working on Ubuntu, you cannot run Windows-based containers on your MacBook or on your Ubuntu desktop. That is not possible. So is the other way possible? Can you run Linux-based containers on Windows? We'll actually see that in the next few minutes. We'll actually be seeing how, if that is even if that is even possible or not, right? So let's actually look at this. So this is the same slide, probably dependence on the OS kernel. So this is how the non-containerized environment looks like. So you have the hardware, and then you have the hypervisor, and then you have applications, virtual machines and stuff. And this is how a containerized application or containerized environment looks like. You have the hardware, you have the operating system, you have something called a Docker on top of it, and then you have containers which are running that, right? So which are using containers. So which is best? Should I only go with this, or should I go with the first approach? Well, it's actually the best of both the worlds scenario that they say. You actually have hardware, then you have the hypervisor on which you create virtual machines. This could be the EC2 instances or the VMs, and inside that you have Docker, and on top of Docker, you actually have various applications that are running with your doorstep, right? So this is the best of both worlds, which is very much needed for the R. Okay. Now let's come into, now that you understand the foundations of why containerization as a technology, let's actually deep dive into the different pieces of Docker that we have. So Docker is one of the containerization technologies that we have. It's not the only, but it is one of them. And Docker, right, has various components to it. The first component that we have in Docker is called as a Docker engine. This is the Docker daemon, which actually runs on the host. It could be Windows in my case, it could be Linux in your case, it could be Mac in someone else's case. It could be the server OS. So Docker is a daemon or the service that is running, which is going to interact with the kernel, right? So Docker engine is what we have. In the Docker engine, we again have multiple versions. So we'll actually be looking into that. There is something called as Docker image. The image is something similar to an AMI in AWS, wherein you had a template that was used to create EC2 instances. So we have something similar called as Docker image, wherein you can create images using Docker. You can create containers using Docker images. Docker registry is a place where you can find all the images. So all of these images can be found in Docker registries. We'll be looking at what Docker registries are. Containers is the actual isolated environment, the runtime environment that is provided. So with using images, you can actually run containers. So containers is what is providing the isolated environment for the service to function. Then you have networks, which is this Docker networks. Then you have mount and volumes, and then you have process. Right. So all of these is something that we will be discussing in depth. Let's go with Docker engine. The first thing, so there are two type of Docker engines that are available. One is the community edition and one is the enterprise edition. Obviously, we will be using the community edition because it's free for development and research purpose. Right? So we'll be including this into our system. Now, how do you get started with Docker? The first thing is you need to install Docker on your laptops. Okay. Now, if you are on, so I'll say Docker desktop. So they claim they are the number one containerization software. That's okay. Download Docker desktop. Now, if you are on Apple and if you're using an Intel-based chip, go with the older one. If you're using the silicon-based, the Apple M1 chips, go with this. If you're on AMD, go with this. If you're on ARM, go with this. If you're on Linux, you can go with this. I am using AMD Ryzen, so I'll go with this. So this is now started to download something. Once it downloads, all I have to do is double click on this and it will start the installation process for Docker, right? I don't want to download it again. I already have that file. Now, once you have that, once the installation is finishes, you will have an application like this. Mac setup is also similar. You will get a DMG file. You need to copy the DMG file into the applications folder and just start Docker, and Docker will be started. Now, as soon as you start Docker, this is what you're going to see, right? This is what I am going to see on my screen. Now, we will not be using the graphical user interface for Docker because on production environment or on the cloud, you would be running Docker on Linux servers. Luckily, unluckily, Linux servers are not going to have a graphical user interface, so you will not be able to see this, right? So for this, what do? I open my terminal. I am using git bash itself. Let's see if Docker is there. Yeah, I just ran Docker and it gave me how to use Docker and stuff, right? So, what is the first thing that I'll do? Let's see what the version of Docker is. Docker hyphen hyphen version. So the version of Docker that I'm using is 27.4.0. The build number is this, probably a git hash or something, but this is basically what we have. Okay, this is how you need to first get your Docker setup so that you could actually run Docker containers or Docker related stuff over there. I don't need this. Right. This is the community edition and you need to follow this step. Make sure that whenever you are trying to work with Docker, Docker desktop should be running on your laptop, right? There are many cases wherein Docker desktop is not running. So how do I stop it? This is Docker. So quit Docker desktop and it will stop the Docker daemon. And now if you type Docker hyphen version, it will give you the version. But if you say Docker anything, right, it's going to give you an error saying that, hey, I don't think Docker is running. Make sure that Docker is running on your servers, on your desktop or your laptop, wherever that is. Okay. Now, I don't want any baggage, so we'll try to start afresh. So give me 1 second while I delete everything. There are commands to do it as well, but I'm just doing it like this. Okay. So this is how I have Docker. Now, how do you get started with Docker? So Docker images and containers. So Docker images. Image is a package or template, just like a VM template, that is AMI that we discussed, which is used to run the container. Docker containers, these are the running instances of the image which are running in isolated environments, having its own process network and volume that we have, right? So that's a container. Container is a running piece of the Docker image or the image that we had. So whatever software is installed or kept inside that image will automatically be running. Docker registry is the next piece. So what is a registry? Registry is a place where you can find all the Docker images. So let's actually look at the Docker registry. That Docker registry is actually called as Docker Hub. So I'll go to Docker Hub, and you could go to hub.docker.com, and it might ask you for a login. You can log in, but I'm totally okay without login also. It should work seamlessly, and this is how it looks like. So I just search for Ubuntu, and here if you see, Ubuntu is a Debian based Linux, blah blah blah, and it has a Docker official image, which means I can use this Docker image to run Ubuntu. Now how do I run it? Again, it's a different story. Let's actually go into the slide so that we know what that story is. So this is the command that we will use to run Docker images or containers in short. Very simple. You just say Docker, and then you say run, and then you give the name of the image that you want to run. As simple as that, right? Now, I will not run Ubuntu as the first image. That would not be good. So what I would run is a hello world Docker image. So that is, I'll say Docker run hello world. It is an image. So hello world is an actual Docker image that is out there. So let's hello world is an actual Docker image that is out there, right? Which we can use to see if the Docker is running or not. Now, what is Docker going to do? As soon as you say Docker run hello world, first it is going to see if this image hello world latest, if this image is present locally or not. It was not there, so it started to pull the image. That is, it downloaded the image onto your laptop. So this is the image downloaded, and now it is running that image and going to give you an output. So what is the output saying? Hello from Docker. Okay. This message shows that your installation appears to be working correctly. To generate this message, Docker took the following steps. Number one, the Docker client contacted the Docker daemon, right? So this is the Docker client. It actually contacted the Docker daemon, that actual process that is running. The Docker daemon pulled the hello world image from Docker Hub, and Docker daemon created a new container from that image which runs the executable that produces the output that you're currently reading. Docker daemon streamed that output to the Docker client, which then sent it to the terminal that you are running it in with. What you're saying, to try something more ambitious, you can run Ubuntu container with this. Okay, let's try this. This should answer your question. Can I run Linux containers on Windows? Yes or no? And the answer is yes, you can, right? If I do a cat etc was release, you see that it is Ubuntu, Debian, and I am on Windows. So if that's the case, then this slide holds no good, right? Then you might argue that this slide holds no good. But in actuality, what is happening is in actual world, what is happening is my Windows laptop actually is using Hyper-V in the background to actually have a Linux VM created, and this Docker that I am running, right? This Docker that I'm running is actually running on that Linux VM, right? And that is the reason why it is able to run Linux based. It's able to run Linux based containers. Linux based containers are only running because I'm using Docker. Uh, Windows is actually using Docker on Linux based system. That's the reason why it is functioning. Okay, so this is how you can run this. Now, here if you see, it says Docker run. From this slide, you only knew Docker run and the name of the image, right? Here also it did the same. Ubuntu was something which was unable to find locally. So it started to pull Ubuntu and then it did all of this. Let's say I exit out of this terminal and I again do this. This time you will see that it did not download all of that stuff. It straight away ran that for us. And that's how it is, right? So if I say host name, you will see that this is something that I get. Now, how do I know the different containers that are running out there? So let's actually go to the next slide to understand the next concepts. So this is what we did. We did a Docker run and the image and it started to run. Now, how do we know what are the different containers that are running on our laptop or on Docker? What are the different containers that are running, the running containers? For that, you need something called as Docker PS. The Docker PS is what you would be using. Here it is going to give you the container ID, and if you match this container ID with this, it should be the same. Ending with B92. B92 is the container ID that it is running. So if I do Docker PS again, it is going to give me this. Now let's say I do an apt get update over here, and it is going to update all the apt repos and everything. And let's say I want to install apt get install httpd. I'm not sure if httpd is present or not. So which one do you want is what it's asking. Do you want a micro HTTPD, or do you want an Apache 2, or do you want an Nginx? Oh god. Let's go with mini HTTPD. I don't know what that is, but let's say apt-get install HTTPD. The reason I chose HTTPD is because we have been using it for some time and stuff like that. Let's say I did the installation and everything is done and I exit out of this container. Okay, I've exited out of this container. Now, if you try to run Docker PS, you will not see anything that is running inside the, like you will not see any container that is running. So that is because as soon as you exited out of this container, what was the purpose of this container? What was the purpose of running this Ubuntu image? The purpose was bash. The bash is nothing but a shell that we have. So as soon as the shell is there, it is going to stay. As soon as the shell is exited, it will exit out of that. That means the container will also stop. So if the service inside the container stops, that means the container outside will also stop. What is a better example that I have? So let's say I'll say Docker run Ubuntu, and I want to do a sleep for, let's say, 10 seconds, right? So what is the Docker going to do? This container is going to run sleep for 10 seconds. And as soon as this 10-second sleep is completed, the Docker container will exit automatically. The Docker container exited automatically. Here if you see again, I am again running it, and as soon as the sleep command finishes, it is going to exit out of it. It's going to vanish. Right here, I don't see any of the containers running because the sleep service which is the primary service that was running, or PID number one, is the first process that is running inside the container, completed its run and it closed. Now, instead of sleep, you could have a Python code, or you could run Terraform, or you could run something else, or something else, and something else. And this is going to behave and work in the same fashion in Docker PS. Now that all the containers are gone, right? Now that all the containers are gone, how do I know a list of all the containers that actually ran on the system? Right? On this Docker, what have been the containers that actually ran? So for that, you can use a command called as ps-a. Right? That probably should be my next slide. If it is, yeah. Docker ps-a is what I should be using, and this is the list of all the containers that actually ran on my system. What you could also do is, let's say Docker run nginx. Nginx is again a web server like HTTPD that we had. So it is a web server, and here if you see, for Nginx it is downloading multiple layers. Now what is layer? We'll actually be discussing what a layer is in the coming classes, but this is actually what it looks like. Now here if you see, you actually have the container running, and this is the log of the container. So the logs of Nginx are actually being displayed on the screen. If I go to a different terminal and let's say to Docker PS, it will show me Nginx is running for 26 seconds. It is up. Status is this, port number is this, and all of this is actually running on the server. So if I kill this, if I do a control C, if I kill it, it will exit. And if you again run a Docker PS, it's going to fade away. If you run a Docker PS-A, you will see that the container was this. Let me minimize it a bit so that it's much clear. So this is the container ID that was created. This is the image that was used. This is the command or the entry point. We'll discuss what a command and an entry point is in the coming classes. But basically, what this is what you have. And each container actually gets a suite name for itself. It's a random name that is generated. It combines two random words and gives you a name. Right. So this is the container name. This is the container ID that we have over here. Right. So how do I stop a container and how do I start a container? So let's actually do this. I'll run Nginx again, right? And this time in a different shell, let's say I say Docker PS and I get the container ID. What I'll do, I'll say Docker stop with the container ID. If I say something like this, stop, it is going to stop the container for us. So here if you see, it exited out of that, right? Now, if you want to start it back, so you could say start, but I'm very doubtful of what exactly this is going to happen. So if you see, the container has started, right? Now, what's the difference? The first time you actually ran Docker run Nginx, it actually ran in the shell itself. It ran in an interactive mode. We call it as interactive mode. So Docker actually ran it in an interactive mode. But when I actually did a Docker start, for that it did not run it in an interactive mode, but it actually ran it in the background, right? My shell is still free for me to use. And now if you see, I actually have two Docker containers running. One is this one where I said Docker start. The other one is in the other shell, which is actually running for us over here. So I don't want any of the Docker containers to be running. So what I'll do is I'll say Docker PS. I'll stop the Docker container. So I'll say Docker stop this, and it should stop the Docker containers. Right? Very simple. So this is how we are going to stop the containers, and obviously we also started the containers, and that is what we have. Yesterday we were running some Docker containers. So let's just get a list of the Docker containers. The command is docker ps-a. You get a list of all the containers that are there on your system. And if you do a Docker PS, we actually don't have any containers out there. So it's only Docker ps-a where all the containers are there. That means all of these containers are currently in the exited state, or you could also call it as the stop state, right? Now, these Docker containers, right, all of these containers that you see on the extreme left, the container IDs, right, these are actually running on certain images. These images are like Nginx image, Ubuntu, Hello World, and stuff like that. Now, to understand or to know what images are there on your laptop, you could run the command called as docker images, which says Ubuntu, Nginx, and Hello World. These are the three images that are actually there in my laptop as of now. Now, the thing that you have to see is the size of the Ubuntu image. The Ubuntu image, the size is only 117 MB, right? It's not big. It's very 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 small when compared to the operating system or the ISO image, which has the entire OS kernel and everything along with it. 117 MB of the entire container is very 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 less. So you have other distributions like Alpine in Docker, which is just like 30 or 40 MB in size. That's right. So there are smaller images as well. So this is something. Now if you want to look at the images in like a pretty form, right, you could use this command. Not that I use it every day, but it's out there, so you could still use that command. If you run this, it's just going to give you it in a pretty format where it says repository tag and size. What is it missing? I don't know. What is it missing? The created date, right? So basically, what we are not having is the created date, which is over here. Now, how do you remove images? Let's say you want to save some space on your machines, right? Now, if you see the hello world image is consuming 20.4 kilobytes, right? It could be any other image. Let's say it is an image which is consuming, let's say 500 MB of space, which is very much possible, right? And if you, as you keep on adding more and more stuff to your containers, that is more and more software and packages and libraries, the thing will keep on increasing, right? So that's the hello world example. Now let's say you want to remove this image or you want to delete this image. How do you do it? So you could say docker rmi, that is remove image rmi, and you will just say the image id. And what is this going to do? It is actually going to delete the image, but before deleting it is going to give you a very small subtle error saying that there is Docker container, this which was run using it, and it is still available. It is, sorry, this is the image. This is the Docker container which is available on your host, Docker host, and it's still there. So what would happen is if you try to delete the image and then again if you try to run the Docker container, that would not start because the image itself is not there, right? So what are we going to do? We are going to do a docker ps-a. We're trying to see if this actually matches with the hello world example. Yes. So the first thing that I'm going to do is docker rm, and this is actually going to delete the container itself. So it is going to delete the container on your system, right? So docker rm is going to delete the container, rmi is going to delete the image, right? Now you see that the image was deleted successfully. Earlier it was throwing us a response. Error response was from the daemon conflict. It was unable to delete the thing. Now if you try to do a docker images, you will see that there are only two images left on your device, that is Nginx and Ubuntu.
Yeah.
Right, so this is Dr. RMI. Okay. Why do I have some slides which are duplicate? I will just keep this. Cool. So we went with this example of deleting the images. So that's something that we ran. Now let's try to understand the life of a Docker container. Now we did go through it yesterday briefly, but I would again try to emphasize on what the containers are actually doing. So if you see, Docker containers only live for as long as the process inside the container is alive. This is very, very, very important critical thing, because whatever process you are running inside the container, right? Now, a Docker container is not like a operating system, like a VM wherein you run multiple processes, right? A Docker container is solely and solely used for running one particular process service that it is going to serve. Right, so there's only one process that runs inside a container, and that process is given as PID number one on the Docker container. So what actually happens is, if I could open a new slide, which should be a blank one. So actually, I have the slides for the process mapping in somewhere later down the course, but let's say there is a Docker container, right? The Docker container is running a process with PID number one. So this is inside the container, but this Docker is actually running on the host, right? Now what happens is, this PID is actually, because the Docker container is not having a kernel of its own. So what actually happens is, another PID, let's say 3214, a random number, is generated or is created on the host operating system, and this is where all the process is running. So now this PID is actually going to reach out to the OS kernel. OS kernel is going to reach out to the CPU, RAM, network, storage, and then it is going to do all of its processing. And once everything is done, this PID is going to send it back to, so kernel is going to send it back to the PID 3214, and this is going to send the response back to Docker container. So this is how the process mapping is done. Now, if PID number one, right, the first process ID itself is not running, and the container will also die, or the container will also be stopped, right? So if the service inside the container is dropped or crashes, the container also stops. Same with the operating system. In an operating system, if PID number one of the operating system, if that goes down, then the OS also shuts down, right? The OS will
Yeah.
also shut down, because the first process ID is responsible for running or booting the entire kernel, right? So something similar happens in containers as well, and this is how it is done. We can take this example that we used yesterday. So let's go with this example, Docker. PS, you don't see any containers running. So let's say Docker run. I would be running Ubuntu, and so I let's say I run sleep for like 20 seconds, right? This is all I did. So what is happening? Docker is running the sleep command. So here, if you see Docker PS in the other tab, right, you see that sleep 20 is being run inside the container, and the container is going to be alive for roughly 20 seconds, up 19 seconds, and now that the container is stopped, if I do a ps-a, you will see that the container exited 4 seconds ago, 26 seconds ago it was created. Uh, Almost all 20 seconds is what it actually ran,
Mm-hmm.
right? So this is the life cycle of the container. Very, very, very important. If the container stops, sorry, if the service inside the container stops, the container will also stop. That is the Docker PS, the Docker container that is running, right? That will also be gone. Very, 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 very important thing. Attached mode and detached mode. This is something also we discussed yesterday. So when we execute a Docker run command, right? Let's say I say Docker run nginx, right? Let's say I'm running nginx. Sorry, the spelling is wrong. Nginx. Let's say I run nginx. So what has happened is this Docker command, right? This Docker run has consumed or occupied my terminal, right? It has occupied my terminal. I can't do anything in this terminal now unless I cancel or control C, unless I interrupt the thing that is running, right? Now this is called as an attached mode. It runs the container in an attached mode. In this mode, the container occupies this shell and would show the standard out log of the container. So whatever the standard output is, we will be looking at that. How to run it in detached mode? All you have to do is say -d. If you say -d, I'll just cancel this out. If you just say -d, that means it is going to run in a detached mode, right? Now, if you do docker ps, you will see that the Docker container is running, and uh, it is not going to stop even if you do a control C or anything, because we are already out of the shell. How do we stop this container? Something that we saw yesterday. We said docker stop stop the container ID, and this should stop the container. Docker ps, nothing is running. Docker ps -a. You see a lot of containers out there. How do we get rid of all the containers? So you can say docker rm. You know, you need to provide a docker ID of individual containers one after the other. Else, what you could do is maybe put something like this docker ps-a-q. This now what is this going to do? Let's first show you this. So what is this going to do? It is only going to give you the container IDs. Now what I'm trying to do is all of these container IDs, I am trying to put it in a dollar, like a variable kind of thing. And what is it going to do? So docker rm this docker ps-a-q is going to give me the list of containers. Now how do we attach and detach a container? Again, it's very, very easy. You definitely would not like to attach a container, but if you want, you can still do it. Uh, you could see any running container that is out there, and then you could say the command is docker attach and the container name. So let's say docker ps, nothing is running, docker run -d nginx. So the nginx container is running docker ps. Now what you can do is docker attach and then the container name, and this will give you the container would be attached to your system, right? So it is now attached. The only thing is you're not seeing any logs because there are no new logs being printed. If you do a control C, you see that there are some logs that get printed and then the container exits, right? So this is basically what is happening with the attach and detach mode of the container. After this, we have a very, 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 very important command in Docker, that is execute. Docker exec. So what is Docker exec? Let's say there is a Docker container. So let's say there is a Docker run Ubuntu, and I want to sleep this for, let's say, 10,000 seconds. Okay. Now, what I also want to do is hmm, okay, the spelling of Ubuntu is wrong. What I also want to do is run it in the what do we call the detached mode. Let's say I put 1,000 seconds, more than enough for our demo. I have this Docker container that is running. Now let's say I want to run some remote commands on this Docker container, or let's say I want to go inside the Docker container and see what is happening, right? So what you can do is you can run the command called as exec, Docker exec. If you do an -it, it is going to give you an interactive shell, right? It is going to give you an interactive shell, and all you have to say is bash. So, right? So this is the command that you want to run, and it has given you bash ps-ef. You see that there are only three services that are running, three processes. PID number one is the sleep process that I was talking about. So whatever the main command was used to run the Docker image, right? So that becomes as the process ID number one. Is it necessary that we always provide the process ID? Not needed, right? So the, let's say the Nginx container that we ran, we didn't provide any command after that, right? We didn't say sleep or anything. We just said Docker run Nginx, and that's it. It ran Nginx for us because Nginx is something which works as a web server, so you don't need any overriding or any additional features to be run with that. But let's say in an Nginx server you want to run something specific, yes, you can then provide what you want. Right? So Docker exec, this is giving you a sleep of 1000. If I exit this and if I now say Docker ps, right, this is not going to delete the container. Make sure this is not going to delete the container. But what you could do is instead of going inside and running ps-ef, you could directly run ps-ef from the outside also. Here, if you see PID number 7, which was bash, which is when we it actually stopped. So the bash process actually exited or stopped when we hit exit. So when we came out of this shell, this process ID was gone. PSFNEF is the 16th process that actually ran on this server. Now it is PSFN. Now this PSFNEF is the 16th process that ran. If I do it again, this would be something else, right? So it keeps on incrementing, and this is how you get it. Let's say you want to check the operating system version, right? So cat etc os-release, release, and it is going to give you release. Okay, not giving it to me. Okay, now that I'm doing a cat, right, you don't actually need an interactive mode also. So let's get rid of the exec interactive mode. Let's just do a cat and see if it even gives. Okay, Docker PS is the container there. Yes, the container is there. So that's actually going to Docker exec again ID, the container name, and then bash, and then go into cd etc ls-l. Do we have os-release? Yes, os-release is there. Yeah, it is there. So then again, cat. Okay, you're getting this. You're getting this error because what is happening is because I'm running this on Windows, right? So this is git bash on Windows, right? So what is happening is docker exec, this command, right, is confusing etc os release to this file actually, right? So what it is thinking is this is the place where it is running the command, whereas the actual place where the command should be run is inside the docker container itself, right? Now there is a fix for that. I'll actually look for that and discuss that in the next video. So there is a fix that we have to there is a command that we have to run prior to running these commands, and that would behave like Linux. But if you run this same thing in a Linux container, this is going to run exactly the same way. So this is actually going to read the /etc/os release of the container and going to give you the output, right? So this is how it actually works. But Docker exec is very, very important if you want to actually understand what is happening inside the thing. Here, if you see, okay, yeah, I have some other terminal as well. So let me open mobile term. Okay, so Docker PS. Here, if I run Docker exec exec, what else is that? This cat etc OSRELEAC release is actually going to give me the thing. Now, why is the difference? So this terminal, mobile term, right? This terminal is actually more closer to the Linux environment. It actually opens a Linux shell itself. So it actually works on a principle wherein it actually creates a local server of its own and then runs everything. Whereas Git Bash is primarily using Windows as a platform. Right? So that's why some of the commands over here doesn't work the way it is supposed to work. But anyways, still going good is what I would say. So this is the Docker exec. The important thing is in real production environment, you're not going to run anything on your local machines. Everything is on a server, and all the commands that we are discussing as of now should work like should work very good or should work very well on the servers, right? There should not be any errors or there should not be any surprises as such. Interactive mode, something that we have already seen. So if you want to run the Ubuntu image in an interactive mode, you could do a docker run -it Ubuntu, and that is actually going to give you a very good interactive session of the entire process. Okay. Now let's actually see tags in Docker, and probably then we will take a pause. So tags in Docker. So what is these tags? So when you're running Docker run Ubuntu or Docker run Nginx, right? So the tag that it is taking is the latest tag, right? So this is the version. Let's say I want to run Terraform, right? So that's also possible. So let's actually see the Terraform repository. So instead of hello world, I will say Terraform. So this is HashiCorp Terraform, right? Okay, command reload. Yeah. So this is HashiCorp Terraform. So if I run, if I say Docker run and just say this, and if I have to check the version of, right, so it is hyphen hyphen version, and it will try to see that the version is not there, so it is going to download the latest version, the image, and it is going to run Terraform hyphen hyphen version for us and going to give us the output, which is 1.12.1. But let's say I don't want to run 1.12.1, but I want to run something older, right? Then you need to go to tags, right? Then you need to go to the tags section of the field, and from here you could select the version that you want. Let's say I want a version which is older than, that is, let's say 1 dot, this is 1.5 dot 1.5.7 is the tag that I want to run, right? So all you have to do is when you are running this entire thing, you need to run it with the tag, which is colon 1.5.7 at the end. So that is Docker run, right? HashiCorp blah blah blah. And if you do a hyphen hyphen VERSIO version, it is again going to download the entire image of Terraform 1.5.7, and then it is going to run Terraform version for us, and it is going to give us the output 1.5.7. Now, how many images do you think are there on our host? There should be two images of Terraform. One is the latest Terraform image, that is with the latest tag, and one is 1.5.7. Similarly, you have Ansible as well, you have Jenkins as well. There are many tools that are out there which can be used. Right, so these are the tags. which come in very, 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 very handy when you are running stuff. So all production environments and everything, right? You will not be using the latest tag. Instead, you would either be having something called as an RC release candidate tag, or you might be having a specific tag number as 1.2 dot something or 25 dot this is 05, right? So 25.05.1 or something. It would be in that section, right? So this is tags. So we'll also be creating our own Docker images, so don't worry about that. We'll also be seeing how an image is created from scratch, and then we would also be using those tags to actually play around with the images. Great. So let's look at ports in Docker. When I say ports in Docker, we'll also be looking at yeah, ports is something that we should be looking at. Now, the thing is, we have been running so we have been running the Nginx container a lot, right? Docker ps-a. You see that we have run the Nginx container a lot. Yeah, one second. If I show you the same command, that is docker rm, this is dollar docker ps-a-q, this is going to delete all the containers, right? Now it was again an error with issue with the this stuff, right? Unless it would have been up. Now this container did not stop or did not stop because it's still running. So if you forcefully want to remove a Docker container or stop a Docker container and remove it, you could say docker rm-f, and that should forcefully remove the container as well. All the images are still there, so I've not deleted any of the images, so the images still remain intact, right? Now let's say I do docker run nginx, that's it, and I want to run it in a detached mode, so I'll do that. Now what you will see is docker has run, right? But is there a way that I can access this Nginx port? It says port number 80. So will it even work? So if I say localhost port 80, does it even load the Nginx page? That's the $1 million question that I would ask. And the answer is no. It's not going to load the page. It says that the site could not be reached, blah, blah, blah. It is not going to load the page for us. Okay, then what do we do? So when you are running the Docker Nginx command, right, what you need to do is provide the port number to which you want to map your system. Let's say I want to map port number 8080 on my local system to port number 80 of the container. If I run it like this, you will see that I have two containers as of now, and the second container is actually mapped to port number 8080 on my local. Now if I run the same localhost 8080, it should actually give you this welcome page for Nginx. Welcome to Nginx. If you see this page, that means the Nginx web server is successfully installed and working. Further configuration is required for online documentation. Please go to nginx.org. Commercial support is also available, blah blah blah, right? So with -p, that is the port number, with -p, which is the port number, we were able to provide an interface between the Docker host and the containers that are running. See, in this example that I have, right? See, all the Docker containers which need to be externally accessible needs ports to be mapped between the Docker host and the Docker container. Obviously, Nginx was a container where we actually had to do the mapping. Now, do we need the same kind of stuff for Ubuntu? No. Ubuntu containers don't need it, right? So Docker ps-a, nothing there. So let's say Docker run -d Ubuntu sleep for 1000 seconds. All the Ubuntu container is going to do is sleep for that many seconds. I don't want to do anything with the container, right? Now you can argue that no, I want to SSH into the container, right? But there is a better way of doing that. So you could do a docker exec exec hyphen it and then the image and then bash, and that should actually give you the shell access of your container. So df-kh, you could run all your Linux commands. It's going to work like a charm, right? So there's nothing actually that is going to stop you from running all of these commands, right? So that is how you actually manage the code. So here in this example, there are like six containers that are running, and for all the six containers, we have like provided different ports on the host, so that they can be accessible, right? So we did something similar. Let's say you want to run another Nginx container. Let's say you want to run another Nginx container, which is this. This time you can map the port number 8081. So what would happen? You would have three Nginx containers that are running, and you could always and always go for 8081 port number as well. So that is localhost 8081, and then that is going to give you a different Nginx instance altogether. So this Nginx instance is different, and that one is different, right? This is different. This is different. So this is a different container. That is a different container altogether. You're getting the output from two different containers, and so this is how you can do mapping of the ports. Now, before I go into volumes, right, I would like to introduce you to Jenkins. So what is Jenkins? Jenkins is a CI/CD tool that is available for us so that we could run certain jobs from there. So I'll say Jenkins slash. You might not know Jenkins slash Jenkins, so you just say Jenkins, and it is going to take you to the this is the official image. So go to the official image and make sure you see when it was last updated.
Okay.
So it was last updated 7 years ago. So that means that is deprecated, and it is asking us to use Jenkins slash Jenkins. So this is the one that we should be using, Jenkins slash Jenkins. And if you want, you can run it with the latest, or you could run it with something else as well. Now, if you want to access Jenkins, right, now obviously you need to read some documentation to understand what it is, right? So this is the actual run command that we have for Jenkins. So what it is asking is to docker run -p with 8080 mapping to 8080. Now we will be getting an error if you map 8080 because 8080 is already consumed by Nginx as of now. We'll have to change that, and this is the thing that we're going to run. So let's actually do that. So I'll say docker run -d. I want to run it in a detached mode. Let's say I want to give 8888 to 8080. Now 8080 is the default port on which Nginx is going to listen. Now this documentation is also asking us to map port number 50,000 to port number 50,000. You can do it if you want, or you could leave it as of now. You don't need it. What it is also asking you to do is restart on failure. So it is asking us to restart the Jenkins server if there is any failure, and the actual image that is Jenkins slash Jenkins. If you don't mention anything, it is going to take the latest version. If you don't mention any tag, it is going to run with the latest tag. That's all we know as of now. So as you see, Jenkins seems to be a bigger image. It's like has number one has multiple layers. We'll discuss what the layers are in the next class. But as you see, the image is still being downloaded. And once the image is downloaded, it will actually run on my container. So image has been downloaded, container ran. So if I do a docker ps, you will see that the Jenkins container is running. Let's actually see what the size of the Jenkins image is. You see that it is already 782 MB size, right? So that's a big image. We have to look at it. Now I don't want all of these local hosts, so I'll get rid of that. And then I'll go with 8888. And here you will see that it is asking me to unlock Jenkins. Now, how do I get this password? Very simple. All you have to do is a cat for this password. Now, cat is not working on our Git bash, so I'll fall back to this another terminal that I have. So I'll do a docker exec, right? And what I want to execute on is this. What I want to do is cat, and what I want to read is this file, right? It's going to give you a one-time or the initialization password of Jenkins. All you have to do is this, and you need to do a continue, and that is going to help you with the installation. So I'll say install suggested plugins, and this is going to start the setup of Jenkins, right? So we are actually installing Jenkins using a Docker file. So we are not doing it like creating a EC2 instance or a VM and then installing Java and then running Jenkins or installing Jenkins. We are directly creating this on a Docker file. So this step is going to take some time, and uh, totally depends on the internet speed and the processing capability that the laptop is having. Now, if you want to speed up the process, right, make sure that you are deleting all the other ones which are not needed as of now. So docker rm hyphen f. I don't want this container. I also don't want this container. I also don't want this container, and I also don't want this container. So all of this gone. If you now do docker ps, there's only one. If you do docker ps hyphen a, then also there should be only one, which is Jenkins. So most of the plugins have been downloaded. It is now going to ask you for selecting the username, creating a username and a password. So let's wait for the username and the password to be created. Admin 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 at gmail.com. So that's not a valid email address, but still works. And okay, save and finish is what I'll say, and start using Jenkins is what I will do. So this is how your Jenkins login page looks like. After you log in, this is what Jenkins looks like. You can create a job. So Jenkins is a CI/CD tool, right? It's a CD tool wherein you could create jobs, which is going to help you run run certain tasks, right? So let's go with a freestyle project as of now and say okay. I just gave a name demo one. I'll not be doing anything. What I'll straight away go is to build steps, and let's execute a shell called as ls-l. Maybe you want to do a df-kh, and maybe you want to do a host name, and you want to do qmi. Right, all of these Linux command is what I'm running. Nothing fancy. I just applied it. I've saved it, and there is something called as build now. You click on that build now. It is going to start the build for you. Very simple, nothing fancy, right? And if you click on that green tick which is there at the bottom, you would see that all your commands that you mentioned ran successfully. lsfnl, there was 0 files inside the directory. Let's actually see which directory it ran it in. This is dffnkh. The host name will be that of the container id, right? So this is the container id, that is actually the host name, and the user with which it is running is Jenkins, right? So this is how the build completed. All good. Okay. Now let's say for some reason what has happened is you accidentally hit the up arrow and deleted the Docker container as well. You actually deleted the Docker container, and if you look at Docker ps-a, you don't have anything left with you. Okay, this is the situation. Now, how do we get the Jenkins back and the job back, right? Luckily, you still have the Docker run command with you, and you would do this Docker run. And what should happen is Jenkins should now be available, or at least it should be available on this port number, that is 8888. But the problem is Jenkins is again went back to the initialization phase. Okay, let's take the risk of initialization and see if that even works, right? So I'll do a docker ps, that is docker exec, and this, and I do a cat, and I do a cat for this. I get the initialization password, initialization, continue. What I actually want to show you is all the data that was written, that is nothing but the job that we created and the logs of that job and everything that was out there is
Hmm.
actually lost. Why? Because the volumes that a Docker container uses is not persistent. So what actually happens is when you run a Docker container, when you run a Docker container, right? So Docker is already having an image, right? Is already
Yes.
having an image which is having this. On top of the image, what happens is Docker actually gets a so let's say I created an Ubuntu image, right? For this, I need to explain it to you in a different way. So give me a minute. So this Docker container has an image, right? Now this image you saw has multiple layers, right? Layer 1, layer 2, layer 3. Let's say my Ubuntu image has 3 layers. Just for sake, we'll see how these layers are being created in the next class, but let's consider there are these layers. So when you actually run a container, layer 4 is created, right? And if you go inside the Docker container, let's say you create a file with vi or touch, or you echo something, and all of that happens, right? So if let's say you create a file, that new file is actually stored on this layer 4. Layer 4 is where all the files are stored. So far so good. What is the command that we ran? So that is docker run hyphen let's say hyphen it for interactive mode, hyphen it. This is Ubuntu. Ubuntu is the image, and I said bash. This is the command that I ran, right? So this, all the files that you create are written in layer 4, which is a temporary layer that is created. What actually happens when you delete or stop the container? Not even stop. Let's say you do a docker rm of the container ID of the container. What happens is this layer 4 is deleted. This layer 4 is deleted. And if you again run the Docker container, a new layer 4 is created, which is not having all of this data. Something similar happened to us with Jenkins. Something similar happened to us with Jenkins. Something similar happened to us with Jenkins, wherein when I said Jenkins run, we did all the initialization, all the plugins and everything were downloaded. So all of this was downloaded. We actually gave the user ID password and actually created a job and ran it, right? But when I did a docker rm-f for the Jenkins container, it actually deleted that layer 4 or layer 5 or whichever layer it is for Jenkins. It actually deleted that non-persistent layer, and we lost all the data. All the DATA data got lost. Now, what is the solution for this? The solution for this is persistent volumes. So persistent volumes is the solution that we provide, right? Now, what is the so persistent volumes is what has to be used in order to save our day. Now, these persistent volumes can be actually created in 2 ways. You could either provide the folder structure in Linux. You could actually provide the folder structure to map it to that of a container, or you could create something called as a Docker volume. I've not created a Docker volume. I don't have the slide for Docker volume create, but let's actually do that. So Docker PS, I'll just stop this container. I don't want it. So I'll just get rid of this. Right, this is gone. Right. So there is something called as volume. So nothing but Docker volume list is actually going to give you the list of Docker volumes that I have. So let's create a Docker volume. Docker volume create. Create. I call it as my Jenkins, and the volume has been created. Now when I am running Docker, that is Docker run hyphen d hyphen p8008. Let's do with 8888 to 8080, right? I'll say this hyphen v. I'll map this thing to where Jenkins underscore home is what I believe it is, but let's get a confirmation with the Docker readme. So here, if you see where Jenkins underscore home is where you need to map it to, right? So I am going to map it to this. That is where Jenkins underscore home, and I'm going to provide the image, which is Jenkins, and that's it. The only thing that we are missing is that hyphen hyphen restart thing. So let me also copy this and put it somewhere over here. So the hyphen hyphen restart should be before the image, right? So here, if you now do a docker hyphen ps, you see that the container is running. This time again, if you load, it is again going to ask you for the initialization and everything, but hopefully this should be the last initialization that happens. So docker exec hyphen docker exec, I want to do it on this container. I want to do this cat, and I want to actually read this file. So that's it. This is the entire thing is the administrator password or the initialization password that is needed. I don't want to do save that. Install plugins, and it is going to do all of this for you. So it is going to install all the plugins for you. Hopefully should take almost on the same time it took last time, but you never know when things go wrong in IT. Now once this initialization finishes, I would be setting up the admin account, and then we'll be creating a job again, and we'll be running the job 1 or 2 times, and then we'll try to delete the entire container over here, and then try to relaunch the container and see if the data is still there or not. That would be our uh, so this is almost completed. ADMIN, 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 ADMIN at gmail.com. Save and continue. Localhost should be fine. Save, finish. Start using Jenkins. Create a job. Let's call it as demo1 again. I'm going to create a freestyle project. Going to click on OK. We'll be discussing all of this in detail when we discuss Jenkins. I'm just going to build execute shell, and let's say lsfm lrdh pwd to understand where the working directory is. df-kh is again that we ran. OMI is what we ran last time. Uh, I guess that should be it. So I click on save. Let's run build now. Build number one completes. Build number two completed. Build number three should also complete. So we already have, let's say there are like 4 builds that we have, right? And if you want to see a trend, this is the trend that we have. And if you want to look at the output of any of the builds, this is the output. And basically, this is where we are. Now, what is the important thing? What we want to do is docker ps docker rm-f. I am deleting the entire container. That means I am getting rid of everything. There is no file related to the container over here. Now, if you want, you could also delete the image also. So let's say Docker RMI this. This is as good as creating a new image altogether. I don't even have the image. I don't even have the container. Let's go to the up arrow. This Docker run hyphen D hyphen P is this. I already have my volume. Hopefully all the data is already written to my Docker volume, right? And I should not be having any errors or issues doing this. So it was not able to find the Jenkins image locally, so it's now pulling it from the internet and it should create the container for us. Great, the container great, the container is created. So let's do a Docker PS. Yes, the container is up. And this time it should not, if I just reload the page, right, it's going to ask me for the username and password. That means all the things that we wrote are intact, right? The job is there. I have 4 runs. I could rerun the job and it is going to run for the fifth time, right? So this is about persistent volumes. Very, 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 very important. Let me do a history because I want to give you the commands for creating the volume as well in the slides. Let's put a new slide. Docker volume. This is number one. And then the command is this. And then the command to actually test it out is this, right? So
Okay.
this is what we have. Make sure that we practice a bit, but this is persistent volumes. In order to retain the data, which is added to the Docker container at runtime, we need to map the volume to the container. This could be a Docker volume, like we did, or it could be some folder path on the host. Now, this folder path on the host is something which is very difficult to make it work in a Windows setup because it needs that additional configuration which I was talking about. I tested it out. It is out there somewhere. I've not noted it down. Probably I'll note it down this time and we could start using it, right? But till then, there's always a workaround, a plan B. You could use Docker volumes and you could play with that. Okay, so this is one way of doing the stuff. Okay, so with this, we can pause for today and let's continue to be continued for day, right? I'll just
Yes.
finish that. So day three will continue from here. Okay, make sense?
All right. Yeah.
Right. So we are almost out there. I would say there are maybe two more classes for Docker left, and we should be able to finish that off, right? So maybe two or three classes for Docker, and we would be able to finish things off. Let's continue with our journey on Docker. So yesterday we discussed Docker volumes, very, very, very important stuff. If you need persistent data, that is, if you want the data to be preserved, Docker volumes is something which is going to achieve you with that. So let's actually inspect the Docker container itself. So let's actually see how many Docker containers are running on my system. First of all, I need to make sure that Docker desktop is running. So the Docker app just started that. So let's see. So if I do a Docker PS, it complains that the Docker is not yet running. So let's wait for this to start properly. Let me increase the font a bit. So if you see Docker PS, I do have the Docker container already running, and if I open this in so if I open this in local port, so that is localhost, was it 8081? No, it is 8888. I should be able to see the login page. The username was ADMIN and the password was also admin, and I signed in. And yes, so this is still working 23 hours ago. And if I just do this, I should be able to do a build number 6, which should also give me a very clear output. Nothing wrong with that, right? Now, this is the container which is already running. Now, let's do a Docker inspect. What is Docker inspect going to do? Docker inspect is going to give you all the details related to the container, right? So it's going to give you all the metadata, every detail, every ounce of detail about the container. Now, if you see, the container ID is not just this number, it's actually a very big number. Uh, so what Docker does is it just shortens it and provides you with this part in the Docker container ID. But in actuality, this is the container ID that we have for Docker, number one. Number two, so the arguments that this is passing is this. So this is something which it is passing when it is starting the Docker container. Totally okay. There should be something called as image. So probably you can do image. So what I can do is grep for image and wow, is not in TTY. Okay. Uh, so grep doesn't work in git bash. TTY. Okay. So this is the image. So the image is Jenkins slash Jenkins, and you could always see the volumes over here. So if you scroll up a bit, you see mounts. Mounts is volume, type is volume, and it is the volume name is my Jenkins, and I have this as the source, and this is the destination to which it is mapped, right? So this is the volume configuration. Now, if you want to get the IP address of this Docker container, so the IP address of this Docker container is 172.70.0.2. Right? This is the container IP address that we are having. Now, if you want, you can also create your own custom containers. The network itself. We'll be doing that after some time. After few more topics, then probably we would be going ahead and creating our own Docker network and everything, right? So that's something which we will have. Now, how do you get the logs of your container, right? So there's again two ways. So Docker PS gives you this Docker logs and then the container ID or the container name. Both of this are going to work properly. So this is the current log that I have on the container. If I want, I can do a control F, which is going to give you a real-time log analysis of your stuff. Let's say I just reload the page. You should be able to see some more logs popping up regarding the container. Let's rerun that. Jenkins is fully up and running. So this is the log that we have about the container. As you see, no errors as such. Everything seems to be working fine. So we'll just leave that as it is. Docker PS. Now the best way to actually look at logs is Docker run nginx, right? So let's run nginx and the port number that I want to map is 38,888 to port number 80. So, okay. So this is the Docker container that is running. Now if I do localhost 38,888, I see this. Now if you do Docker logs for this container, right? This is the entire container. If you do this, and if I am able to reload the page once or twice, you will see more lines being added to the setup, right? Yeah, so this is the real-time live, this is real-time logs of your setup, right? The more I reload, the more logs it gets generated. So this is control F. This is just to show you that it is real-time logging that is available. So command is docker logs and then the ID, and that is it. Now Let's actually look at something called as variables in Docker. What are variables, right? So for this, what we can do is actually create a file. So for this, we will actually be using the Ubuntu container, and we'll try to pass in some variables so that the Docker container runs with those variables, right? Very simple, nothing fancy about it. So let's actually do that. Do I have the Docker image? If you do Docker images, it will show you that yes, the Docker image is there for Ubuntu. So what I do is docker run -it interactive mode, right? What we will first do is Ubuntu, and then let's say bash vi. Is vi there? Vi is not there. Apt get install vi bim wow apt apt get update. We need to first update the stuff. Once it is updated, then we would be installing vi editor over there. No, unfortunately, we have to do this twice. The first time we will be doing it is the without the variables being exported. The second time we do it, we'll do it with the variable being exported. So let's actually see how that is done. Wow, a lot of packages being updated. Okay, for some reason this is time taking. apt get install vim apt get install. Oh, 72 MB. For some reason, the network is taking a lot of time. What do we do? Hmm. Okay, let's move on to the next. In Docker, I'll go to Docker file, then we'll come back to variables. Okay, let's do that. So how do you create your own image, right? So far, what we have been looking at is it complete? Wow, I'll say 9. Why is it even asking me all of this? I'll say 8. Okay. Vi run.sh. I go into Z mode. This is $BATCH batch number of the series. Right. So basically, what is going to happen is, let's say I run this run.sh. Let's say I run this run.sh. So what is going to happen is, wow, bash run.sh, vi run.sh. You need to give a shebang bin bash blah blah blah. Shebang bin bash run.sh. Command is not found. Sorry. What did I do? We actually need to echo this entire stuff. Echo the entire thing. So that's what it was complaining that this is, and if you see, there is no variable that is being passed, and that's the reason why it is showing us an empty space over there. So what I'll do is I'll export this, export without the dollar symbol. So this is batch number 38. So I'll just export this. And now if I run .sh, right? So here you see that there is this variable 38 that is passed, right? So basically this is what is happening. Let's open a new new terminal window, right? And let's say docker ps. So what we are going to do is let's run this docker run hyphen d. Like I want it in interactive mode, so yes, hyphen it. And then what we are going to do is Ubuntu is the image, and before Ubuntu I need to pass the environment variable. So hyphen e batch batch underscore number is equal to 38 is what I would pass, right? And then I just need to run Ubuntu. But the problem is we actually don't have the run.sh over here as well, so we would again be facing the same issue. But then if I just echo dollar batch number, it should give me this thing. Now what I can do is let's echo the same statement that we had. Let's echo all of this into a file called as run.sh lsfnl. Let's do a cat for run.sh, and you see that cat is this. Now what had happened is because we did an echo with batch number, right? So it actually gave me, it actually took the number from the environment variable and actually pasted it over here. So this is 38 being pasted, even though I only pasted batch number. So it actually gave me this thing, which clearly says that yes, the variable has been exported or imported into. Okay, so this is one example that we can uh, echo batch number, and this is going to give you this. So let's say I echoed something else, right? So I say batch number 338, right? And if I now echo dollar batch number, right, I should get the number this. And if I echo this statement into, let's say, run.txt, I'll not paste it. If I do it under run.txt, you will see that batch number 338 is now coming up. That means the variable is actually taking its own value. So at least the variables are working fine, right? So that is one way in which you could actually pass in those stuff. Now I don't want these containers to be running, so docker rm-f. I'll get rid of all the containers. Yes, there is a better way to do it, but it didn't work on GitLab, so Git bash. So I'm not going to dwell into that. Docker ps and a. Still some are working. So what is docker ps? Jenkins is still working. Docker rm-f. Why it didn't stop? Again, stop. Docker ps, nothing out there. Docker ps a. You can get rid of these images also. So that is docker rm-f. Everything is clear now. Docker ps-a. I don't have anything else. Docker images. Yes, we have few images, but we will keep that to the list. Now we are going to do is we are going to see how to create our own Docker file, right? So let's actually see how you can create your own custom images. What does a custom image mean? We'll take the same example, wherein what we did is we can take the Ubuntu server, and then what we can do is actually install the VI editor, and then we could actually also do install curl, and then we could try to test it out, right? So that is something that we can get it done. So how does a Docker file look like? Now what we are going to do is we are going to see how to create our own Docker file, right? So let's actually see how you can create your own custom images. What does a custom image mean? We'll take the same example, wherein what we did is we can take the Ubuntu server, and then what we can do is actually install the VI editor, and then we could actually also do install curl, and then we could try to test it out, right? So that is something that we can get it done. So how does a Docker file look like? A Docker file is a configuration file, right? Number one is a doc. The Docker file is a configuration file which looks something like this, wherein you have instructions and the argument. So the first line of the Docker file is from, and you're going to select the base image that you're going to use. So if the base image is something else, let's say the base image is Nginx, you can use Nginx. Let's say your base image is Ubuntu, so you could have Ubuntu over here, right? So this is the base image, and then you could use run commands to install packages that you want to be installed on the server, on the Docker container, and then you have something called as an entry point or a CMD, which you can use to execute the stuff. Now it could look intimidating at the starting, so let's actually go through it with an example. Do I have some examples over here? Let me see. Okay, so this is a bigger example of Flask or something of that sort, but let's actually see how a Docker file is created in the first place. CDC, CD code, CDCP code, LSFNL. So let's go into Docker and see what's already there. Oh yeah, there is a Docker file. So let's actually see what's there inside the Docker file. So this Docker file belongs to Jenkins, so I'm not going to touch that. LSFNL again. Let's go into, okay, let's go into our batch number 38. Okay, let's create mkdir. Let's create a folder called as Docker. Let's go into the Docker folder. Nothing there. I'll open this in Visual Studio Code, and you have an empty directory. The first thing that I'm going to do is create a file called as Docker file. Now what you need to make sure is the Docker file should always be named as Docker file. Don't provide anything else. And I'm going to use Ubuntu as my base image for my entire setup. The next command that I'm going to do is run. And what are we going to do? apt get update hyphen y. What is the next command that I want? Let's say I want apt get ins install curl and vim with a hyphen y. What is this going to do? This is going to create my Docker container. What is it going to do? The first step that it is going to do inside the container is do a yum update, sorry, do an apt-get update. Once the package is updated, then it's going to install curl and vim on my system, right? And then I have something called as entry point. What is the entry point? The entry point actually is a combination of uh, so the entry point is the actual command that or the actual process that is going to run when the Docker container comes up. So when the Docker container is created, the process that you want to create is something which we will keep in the entry point. So here I have some examples. So let's actually see which example suits us the best. We'll take the example of a curl command. So okay, I don't have the example of a curl command, but let's okay, yeah. So this is the example of the curl command that I have. So now that we have installed curl, right? What am I going to do? I'm going to define the entry point as curl, and the URL that I want to do a curl, right? I can pass it as a CMD command, CMD. Now, what is the difference between CMD and entry point? I'll just show that to you. With first, I would not define the entry point, but let's define the CMD. CMD is, let's say, sleep for 1,000 seconds. Okay, this is what I'm gonna do. And so what am I going to do with this Docker container? Number one, it's going to pull from the Docker base image of Ubuntu. It's going to do a yum update, apt-get update. Then it's going to install curl and vim on it. Then what I'm going to do is I want whenever I run the Docker container, like right, or the image, what I want is the Docker container should go to sleep. Let's actually do that. Now, how do I create this image out of it? I only have a Docker file. So what I need to do is docker build build is the command that I need to use. -t is a tag. I'll call it as my sleeping VM, right? And I will just say a dot as a placeholder because the Docker file is inside this folder. I'll just say dot. And what you will see is the Docker image is being built. What is the first stage? One of three. It is going to pull the image from Ubuntu. What is number second layer? The second layer is it is doing a yum update -y. So that is the second layer that it is doing. Once the yum update finishes, the third stage or the third layer is apt-get install 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 curl and vim, and once that is done, the image should be ready with the CMD or the command that it runs or the start as sleep for 1,000 seconds. So let's actually see how that runs. So now you see that layer 2 completed. Layer 3 is apt-get install curl and vim. So that is also being done. I hope that it doesn't ask me for all the geographical location again. Okay, exporting the layers. This is done and our Docker image should be ready in like few seconds from now. So what I will do is Docker images. So here if you see, my sleeping VM has been created. Now, if I run this -d in a detached mode, if I run my sleeping VM, the sleep is there. There is a small change that I need to do. I need to just give the command as sleep, and now that I have changed the Docker file, right, I cannot be using the same latest tag. So what I will do is I'll create a newer tag, call it as 0.1, and I will run the setup again. Now what has happened? Because it nothing has changed in layer 1 to 3, it was very quick. And if you do Docker images, I should have a new version of my sleeping VM, which is this. Now if I say docker run -d my sleeping VM, which is this, but the tag is 0.1, and if I need to pass an argument, let's say 10 seconds. So what the container is going to do, the container should docker ps -a. The container should have actually run for those many seconds, but it didn't. So let's actually see why. Unable to start the container process except this. Okay. So if you see, when we pass it as a CMD, nothing is happening. The reason is you need to pass an entry point for sleep. The entry point is the command that it is going to execute. CMD is, let's say by default I want it to sleep for 10 seconds. So how is it going to execute? So entry point is equal to the command is equal to the entry point, and the argument is equal to the CMD that we have. If I have to put it in other words, sleep 10 seconds means entry point and CMD combined together. Now the difference is CMD can be updated, but entry point can never be updated in a Docker container. So the entry point always remains the same. What do I mean by that? So let's actually create a new image and then I'll show you. So Docker build hyphen t. So that is my sleeping VM, but this time it is version 0.2 dot. So now you see some more changes, and if I do Docker images, you see a new image is created. 0.2 is what I need to run. So if I now do a Docker run hyphen d this, it should not throw any errors and just run. So Docker PS, you see that the Docker container is running and it is going to run for like 10 seconds and going to destroy itself, because the main command or the main entry point that I selected was sleep. The argument that I passed was 10. But let's say you want to run this Docker command for 30 seconds, right? All you need to do is give a space and provide the CMD. What is it going to do? It is going to run the command. It is going to run the Docker container for 30 seconds of sleep. If you look at this, the sleep is the entry point, which is always constant, cannot be changed or never be changed, and CMD is something which can be changed, that is the variable or argument, right? So I was able to change the argument to, let's say, 30 seconds. Getting it? Now let's say I want to see if curl is there or not, right? First I'll go into the interactive mode. What happened? Okay. Now, if you see, I was not able to do this. Docker run hyphen it sleep, and when I gave bash, right, I was not able to log in into, or I was not able to execute. Why? Because the entry point says sleep and bash is the argument. Now, this command is not valid in Linux, right? Sleep always should be followed by a numeric value that determines the amount of time it is going to sleep in seconds. Right? So that's the reason it did not work over here. Now, how is it going to work? Very simple. So you already have a Docker container that is running. Okay, it actually stopped. So let's run it back. This time I'll give the sleep as, let's say, 300 seconds, which is equal to 5 minutes. Docker PS. How do you verify that curl is running on the system? A curl is there on the system. So you can do something called as docker exec -it this, and you could say bash, and you would be allowed into that. You could just type curl and see if curl is working or not. Yes, curl is working. HTTPS google.com is going to give you this, right? So it is working. Curl is working. We have verified this by going inside the container and looking at it. But how do I change my this Docker container, right, or this Docker file to also now support curl, right? Because the entry point is sleep. With this particular Docker image, right, my sleeping VM, with this particular image, I cannot perform any curl operations. You can do anything in the world, but you will not be able to perform curl operations over here. HTTPS google.com, you will not be able to do the curl operations. What happened? Let's actually see. Is it working? No. It's still doing a sleep 300. Oh no, sorry. This is the older one. If you see, this one just exited with 1. that means it had an error. If the exit is 0, that means it is okay. If the exit is 1, that means it had an error and it was not able to do it. Now, if you want to see why, Docker logs for a right sleep invalid interval time interval https google.com. So because sleep only and only accepts that, so we are not able to do it. Now, how do I change it? If I have to change it with curl, right? If I want this Ubuntu container to play with curl, I need to do something like this. I can then provide https google.com, right? And then I could change the variables according to my wish to get it done. Now let's again build the container, but this time I'm not going to name it as my sleeping container, my curl machine, and I'm going to do it like this. Let's give a tag of 0.1 and what happened? It didn't work. Why? Because Docker build, I need to give a tag for t-t and then all of that follow. So this is now going to create this. And if you now look at images, you see that there is a curl machine that is out there. If you do Docker run a hyphen D or not hyphen D is going to work the same way. So I'm not just doing anything. You see that it is going to do a curl for https google.com and it is going to give me an output. But let's say I want to curl for https facebook.com. I guess it is www.facebook.com. So let's do this and see what happens. Yes. Now this time this was able to do a curl for facebook.com because I provided a new argument. The argument over here behaves like a CMD. The argument over here behaves like a CMD. Then you could have an obvious question. What is the argument for the Ubuntu image itself? So Docker Hub Ubuntu. What is the entry point or what is the argument that we have? I guess the entry point that they have for this is bash. Right. So let's actually look at the documentation if they have any Ubuntu. Okay. So here if you see, they have provided the instead of providing the entry point, they actually provided the CMD, and what they have provided is bin bash. So this is how they are actually doing this, right? So this is the command that they are running when they are initializing the output. Hope I was able to make some clarity on entry point in CMD. So in a nutshell, entry point is something which is constant, cannot be changed. So for every Docker container, right, the primary job of the container is to run only one service, and that service is PID number one. Now, which service it is going to run is totally dependent and described by the entry pointer. So if you say that the entry point is curl, then the Docker container, the whatever Docker container you build from this is going to run only curl for you. Let's say you define the entry point to be sleep, then the Docker container is only going to run sleep. Whereas CMD is something like an argument because curl needs a URL, sleep needs a time interval in seconds. You can provide these two things and that is going to work perfectly fine. So CMD is like an argument that you pass. The good thing about CMD is you can update the CMD when you are actually running the container. So when you actually run the container, you could update the CMD over here. So this is the CMD part. This is the argument, nothing but the CMD. And that is something that you can do. But you cannot change the entry point. Very important stuff, right? This is also an interview question. So entry points is something that cannot be changed, whereas CMD as an argument can be changed. Now let's quickly look at the Docker storage part, wherein if you remember right, for everything there was a layer created, right? So we actually had a layer by layer creation of the Docker image that we saw. So let's actually see. So layer one of three. So there were three layers. Why three layers? Because my Docker file actually has three layers. The first layer is from. The second layer is apt-get update. The third layer is this, right? So these are the three layers that it has. Now let's say I add a new package. I let's say I also include Python over here. Let's say I say Python 3 or Python over here, and I save it. Now, if I run the same package, let's say I build a new image called as, okay, I'm not in the right directory on this, so let me close this window. Yeah. So let's say I say docker build hyphen t instead of machine, I'll say new box, right? New box. So what you will see is image number one of three remains the same, image number two of three remains the same, and the third image is where it started the installation, wherein curl vim python, the package python is not available but is referred to another package, blah blah blah. Python is Python 3. So what I need to do, I need to change it to Python 3 and rerun the thing. And what this is going to do, it is not going to create the first two layers again. It is going to reuse the first two layers. It is now adding the third layer, that is Python, and then giving us the output. So these are the three layers. And now when I actually run the Docker container, a fourth layer, which is a read-write layer, gets created. Right? All the layers that are there in the image are read-only layers. This is read-only stuff. But whatever I get after the Docker run is actually a read-write layer. In this layer, is where you could actually write all the data. But then if you don't have a volume mounted, that is -v, if you don't have a volume mounted, this read write layer is something which will get deleted when the container is deleted. So make sure that you are having that uh, file defined, the hyphen volume defined, so that we could have the entire thing. Right, so this is about the image layer and the container layer. The image layer is only read only, container image layer is read, right? And that is how this entire thing is looking. Make sense? So we have multiple examples of entry points. So the entry point here is sleep, and what you can do is change the arguments over here, and that is going to give you better understanding of what the entry point arguments should be. The next topic is Docker network, which I will not be starting now. We will be discussing Docker networks tomorrow. With that, we will be coming to the end of Docker, and most probably we'll also be starting Jenkins or continue using Jenkins. So we would be spending some time with Jenkins tomorrow. Okay.